Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we see the problems of continuity. In this problem, we have to discuss whether the given function is continuous or not at the indicated points. As compared to previous problem, this problem is quite difficult. The question is f of x is equal to sine of 2x upon square root of 1 minus cos 4x, comma 0 less than x less than equal to pi by 2 is equal to cos of x upon pi minus 2x, comma pi by 2 less than x less than pi, and add x equal to pi by 2. So in this question, we have to discuss whether the given function is continuous or not at indicated point x equal to pi by 2. Now let's see the solution. First of all, we start with left hand limit, that is limit extends to pi by 2 minus f of x. So that equal to limit extends to pi by 2 f of x. Now extends to pi by 2 minus, it means x should be less than pi by 2, and for that we have for 0 less than x less than equal to pi by 2, that is x less than pi by 2, we have f of x is equal to sine of 2x upon square root of 1 minus cos 2x. So the next step will be is equal to limit extends to pi by 2. Now for f of x we substitute sine of 2x upon square root of 1 minus cos of 2x. So that equal to limit extends to pi by 2. Now for sine 2x we use trigo formula, that 2 sin x into cos x whole thing divided by square root of, now 1 minus cos 2x, that is also by using trigo formula we get 2 sin square x, that equal to limit extends to pi by 2, we write 2 sin x into cos x as it is in the numerator, and denominator on simplifying we get root 2 into sin x, that equal to limit extends to pi by 2. Here we cancel sin x from numerator and denominator. Also the 2 can be written as root 2 into root 2 into cos x we write as it is, and upon root 2. Now again here we cancel root 2 from numerator and denominator. So that equal to, now here root 2 is a constant term, so we take outside the limit. So we left with root 2 into limit extends to pi by 2 cos x. So that equal to root 2 into cos of, for x we substitute the limit pi by 2, and that equal to root 2 into, now cos of pi by 2, that is cos 90 degree, and that gives 0, and root 2 into 0 we get 0. So in this way the left hand limit, that is limit x tends to pi by 2 minus fx, is equal to 0. Let us this denote as a equation number 1. Now second part, that right hand limit. So therefore limit x tends to pi by 2 plus f of x is equal to limit x tends to pi by 2. Now pi by 2 plus means x should be greater than pi by 2, and from question that pi by 2 less than x less than pi, that is pi greater than x greater than pi by 2, we have f of x is equal to cos x upon pi minus 2x. So here for f of x we substitute cos x upon pi minus 2x. Now that equal to limit x tends to pi by 2 cos of x. Now here from denominator we take 2 common. So we have 2 in bracket pi by 2 minus x. Then here the rules of limit for cosine function is a limit x tends to 0 cos x is equal to 1. It means for cos function the limit should be 0 to get rule, and present case the limit is x tends to pi by 2, and therefore in this case we put x is equal to pi by 2 plus h, as x tends to pi by 2 and h tends to 0. So it means whenever x we have to put pi by 2 plus h, and for limit x tends to pi by 2 we have to write h tends to 0. So the next step will be is equal to limit h tends to 0 cos in bracket pi by 2 plus h upon 2 bracket pi by 2 minus. Now for x we write pi by 2 plus h. That equal to limit h tends to 0. Now cos 90 plus theta, so that gives minus sin theta, and therefore cos of pi by 2 plus h gives minus sin h upon 2 in bracket we write pi by 2 as it is, and if you open the curly bracket then we get minus pi by 2, then minus into plus minus h. So 2 bracket we write pi by 2 as it is, Then if you open the curly bracket, then we must have minus pi by 2, then minus plus minus h in the denominator. Then if you observe here, we cancel plus pi by 2 and minus pi by 2 in the denominator. So the next step will be limit h tends to 0. We have minus sin h in the numerator upon 2 into minus h, that is minus 2h in the denominator. Cancelling minus sign and taking the constant term 1 by 2 outside the limit, we have is equal to 1 upon 2 into limit h tends to 0 sin h upon h, and that equal to 1 by 2 into 1 by using limits rule, and that equal to 1 upon 2. So in this way the right hand limit, that is limit x tends to pi by 2 plus f of x is equal to 1 by 2. Let us this denote as a equation 2. Now third step of question is f of pi by 2, that is when x equal to pi by 2. Therefore f of pi by 2 is equal to, now we have f of x is equal to sine of 2x upon square root of 1 minus cos 2x, comma 0 less than x less than pi by 2. So here for x equal to pi by 2, we have the function f of x is equal to sine of 2x upon square root of 1 minus cos of 2x. So sine of 2 into, for x we substitute pi by 2, upon under root 1 minus cos 2 into pi by 2. So is equal to, now sine of, here we cancel 2 from numerator and denominator, so we left with sine pi upon under root 1 minus cos pi. So that equal to, now sine pi gives us 0 upon square root of 1 minus cos pi gives minus 1. So that equal to 0 upon square root of 1 plus 1, and that is 0 upon square root of root 2, and that equal to 0. So in this way f of pi by 2 is equal to 0. Let us denote this as a equation 3. So from equation 1, 2 and 3 we get limit x tends to pi by 2 minus fx is equal to f of pi by 2 and not equal to limit x tends to pi by 2 plus fx. And from this, we conclude that f of x is not continuous at x equal to pi by 2. So this is a required solution for the given problem. Thank you.